my student-directed study, I'm doing how physics impacts strength, understanding how moment arms, torque, and technique will impact the bar and how much weight you can lift. How does physics impact lifting? The longer the moment arm, the more torque required to lift the same weight. Someone with worse leverage for a lift will have to produce more force to lift the same weight. As you can see from this illustration, the longer the moment arm, the way harder it will be to lift the same thing. What exactly is torque? Torque equals the moment arm multiplied by the force. The longer the moment arm, the more force you will have to produce to get the same torque. How specifically does this impact powerlifting? Say, for example, squat. For any lifter, genetically shorter femur will lessen the moment arm to the hips and knees, making the lift easier. As you can see on this illustration, the lifter with the longer legs and a shorter torso has a much longer moment arm between his hips and his knees and the bar, whereas short femur lifter has way less moment arm, making the lift way easier. Another good example for this, or another utilization of the moment arm, is where you hold the bar on your back. If your hips are much stronger than your quads, which is your knee, you might want to lower the bar on your back, so you have to bend forward more, which will increase the moment arm to your hips but decrease it on the quads. This is known as a low bar squat, where you hold the bar lower on your back, and most powerlifters employ it. Bench mechanics. Shorter arms decrease the moment arm. And another thing you can do is tuck your arms into your sides more. This is the best illustration I could find. If you tuck your arms in more towards your sternum rather than your upper chest, it will decrease the moment arm with how far away it is from your center of your body. So this is another thing powerlifters do, is they'll tuck their elbows down to their sides and arch their back to decrease the range of motion and the moment arm. Deadlift mechanics. This one is probably the most beneficial to have good leverages. It makes a massive difference. A short torso and long arms will favor the deadlift. Sumo, which is when your legs are outside your hands, will also decrease the moment arm by widening your base, which from a side view will be equivalent to shortening your legs. So as you can see from these lower illustrations, the guy on the left, he's starting with the bar. He's pretty much already standing up straight with the bar on the ground, whereas the guy on the right with longer torso, shorter arms, has to bend over way more. And from the illustration on top, this kind of shows it even better, just how much of a difference it can make with your leverages. So that's why deadlift is such a big deal. That's another good thing about powerlifting, is short legs help you in the squat. Short legs and a long torso is way better for squat, but way worse for deadlift. Long arms is good for deadlift but bad for bench. So if you're good at two of the lifts, chances are you'll be bad at least one. That's why it's so good and makes it even for a bunch of different body types, is because however you're built, you will not be great at all the lifts. Now, for a personal example, I have two lifts here. The one on the left is sumo with a shorter moment arm. First time I ever did it. And the one on the right is conventional with my legs inside my arms with an increased moment arm. This, debatably, I was way weaker on the one on the left doing sumo, and I still lifted way more. At that time, my conventional was 495, and in that video, I'm doing 545 sumo. On the right, I was way stronger. It's the best I've ever done, and it's still only 525 conventional because the moment arm is so different. I'll play it now. As you can see, 545 moved quite handily, and I was way weaker than I am on the right. I was about 10 pounds lighter there, moved pretty easy, decreased moment arm. Now for the conventional. It moved absolutely terrible, as you can tell by my face. That's 525 right there. I'm way stronger there than I was on the left. Now you lift way less. That's a big argument in the powerlifting community, is sumo cheating. It's allowed in competition, but lots of people are mad with it because people who are built perfect for deadlift have to move the bar about 2 inches and they get a lockout. I personally do believe sumo's cheating just because the moment arm is so much less. It really favors people with a short torso, even more so than normal deadlift. to show better how the torque can affect the lift, I made two little things here. This one is conventional, this one is sumo stance deadlift. And say sumo, for example, as you can see, the moment arm is 40 centimeters, just as an example, whereas conventional, way more bent over. You can see my back angle is a lot sharper than this one. So the moment arm is 50 centimeters. Let's say I'm lifting a force of 100 newtons in each one. The torque required by my hips will be much higher in the conventional. This is the formula for torque. In this sumo case, the torque will equal 40 newton meters, whereas in conventional it will equal 50. Now, this is not a one-to-one comparison because different muscles are worked in different stances. This one will be a lot more spinal erectors on my back, a lot of glutes, a fair bit of hamstrings, but not really for me because my stance is so bad. I'm built terrible for deadlifts, so the hamstrings do play a part, but not massive. And I do use quite a bit of quads to get the weight off the ground, but for the majority, it's my hips doing it. It'll mostly be spinal erectors and glutes, whereas in a sumo stance, your quads do have to push quite a bit harder to get the weight off the ground because your knees are pushed out to the side. But your hips will be worked quite a bit less. It's way easier on the lower back. Yeah, that's the math, which is why if you have lower back issues, sumo might be better. And that is my presentation.